So I'm Farhan, and for the progress as far as what we made on our project, I was responsible for doing the Mux Select line for our RM cell. And to do that, we've decided to go with mechanical relays instead of actually with the traditional like analog mux. And the reason being was because one, we felt that it would be more effective. Two, the voltage and or the current restraints would be a lot lower, and it wouldn't heat up like our overheat our board. And we're currently, as far as current process with the mechanical relays, we are prototyping with various devices, trying to see which relay device would be best, and then building our selection network based off of that.
So the part that I'm working on right now is the MOSFET, the current limiter, that is going past the actual memristor. And I started off working with how to get that thing into triode, getting it from triode to saturation right when we switch to our low resistance state, and back and forth between the different switchings. And the issue that I'm having with that is making sure that depending on what resistance our low value is for the mem resistor, because every RM cell might not be the same, I need to be able to determine different equations that can bias our MOSFET effectively, no matter what our memristor low resistance and high resistance values are. And so I'm having trouble with that, and that's what I'm kind of working on right now with being able to get it into saturation no matter what our resistance values are.
I'm Matt, and I'm working with our Arduino. So we're going to hook up an Arduino to our PCB in order to take in millions of measurements. So making sure that I can take in 4 analog inputs of the Arduino, make sure they're simultaneous, and that there's no noise with any of them, and then implement some programming so then we can take in our data, shoot it out to some Excel plot distribution so that we can further analyze our chaos theory and physically encodable function.
Hi, and my name's Tanner, and so my part was to design a ramp voltage. What we decided to go with was a Schmidt trigger followed by an integrator, both tied together. So what's going to happen is the Schmidt trigger will begin to trip to one of the power rails, and this will produce a square wave. This square wave will then get fed to the integrator, which will then integrate that square wave into this ramp voltage that we need. And the output of that ramp voltage, that integrator, is going to feed back into the Schmidt trigger, which will continue to produce our square wave, which then in turn drives our integrator. And so we're just working on some of that, having a little bit of trouble with LT Spice. LT Spice doesn't like the fact that there's no real input into either of the op amps, and so we're trying to figure out a way to get around it, whether it's a different simulator, a different spice, but overall the circuit's working pretty well, and we're looking good.